Hi, just a quick video to show you what I'm playing around with at the moment. I just scored this very nice Advantest R6142 programmable DC voltage current generator. In fact, it's almost like a voltage and current standard. Its specs are pretty darn good, as we'll take a look at. And I scored this on eBay for about $300. And if you're not aware of Advantest, they are a huge Japanese company who primarily make automated test gear for like the semiconductor fabrication industry and stuff like that. They're a multi-billion-dollar company, make real high-end, high-spec gear, but they also make some reasonably, well for them, sort of low-end gear like this, and they do spectrum analyzers and a whole bunch of other stuff. And this is a real nice bit of kit. And we'll take a quick look at it, and I'll show you what I'm doing here, because I've just done a couple of days worth of data logging on this thing, and you would have seen a couple of updates on my Twitter feed for this if you were following along at home. And I just wanted to see like how accurate and stable it was for generating, in this case, a 1 milliamp current over time, not only for absolute accuracy but for drift as well. And you may have just heard that my aircon just turned off here, and I've been doing some that's where I turned the aircon on this morning when I came in, and it ramped up, so I've sort of like had the aircon off and on. And we'll take a look at what this data actually means, and see how good this is for calibrating my microcurrent, for example, because there's not too many really precise current generators on the market, and this is certainly one of them. And yeah, so is it good enough to program a microcurrent? Nominally 0.05%, so it's got to be better than that. You notice my battery letters flash in there. That's a feature, of course. The battery is of course low, so what it does, that's just the ESR of the battery there. When it turns on the LED, of course, it draws more current, which then drops under the voltage threshold of the comparator there. Really quite a neat little, unintended side effect there, but I like that feature. So we'll take a quick look at the data sheet, and this is basically, the data sheet's all I can find at the moment. I haven't been able to find a full user manual for the thing, let alone a service manual. So if you do have those, please leave a link in the comments. Large capacity up to 32 volts, 160 milliamps. I would have liked it to go up to an amp, and on the low side as well, but well, you can't have everything. High accuracy, 0.03%, high stability, low noise, 3 millivolts peak, 50 milliseconds settle-in time. And here it is. The unit precision voltage and current generator is ideal for evaluation of precision circuits and parts, as well as calibration of temperature controllers. Units use a time-sharing D to A conversion circuit, which provides excellent linearity and stability. There you go. So it's and it does. It's also got it's programmable as well, hence because they're really into automated test functionality and things like that. So it's got 160 step memory, and it's 6-month guaranteed accuracy, 0.03% for voltage and 0.035% for current, and that 3 millivolt noise is 1/5 of their previous model. I don't know what the previous model is, and there's probably another model after this as well. I'm not sure of the age of this thing. It might have a date code on the back. I forget off the top of my head. We'll check it out. But anyway, the Advantest stuff, like a lot of the high-end manufacturers, over-engineered. So that 0.03% is going to be very conservative. So we're going to get, I think, well within inside that sort of accuracy. In fact, if we go over here and have a look at some of the specs, we're looking at voltage generation. They're the ranges. It's only got 3 current ranges. As I said, I'm a bit disappointed that it's only got 10 milliamps and 100 milliamp ranges. So I would have liked to generate microamps or something like that, but this isn't designed for low current. You'd have to get like a Keithley current source or something, although I'm sure Advantest, if you pay big dollars, will sell you a low current source generator, most likely. But overall accuracy, we're talking 0.03% there, plus 5 plus a small percentage, plus a small range error there, and 0.035%. But if you're talking 24-hour stability, it goes down to 0.01%, which is pretty darn good. So these specs are essentially, and because it's likely over-engineered, good enough for calibrating a 0.05% microcurrent. And the temperature coefficient here, i.e. the parts per million per degree C, is in the order of 20 odd ppm per degree C. Not bad, although my HP34461A here I'm using has a nominal 5 ppm per degree C. So it's like at least 4 times better than that. And we won't worry about the plus offsets on the end. We'll just, you know, keep things a bit simple for today. And on DC current though, my Advantest meter which we're using actually does go up to about 20 on the current. So it's going to be, for the current measurement here, the drift of my Advantest meter is, you know, about roughly equivalent to this Advantest unit, or at least these are going to be worst case figures. Now let's have a look at what the data up here means that I've been getting. You'll notice I've been logging for almost 1 day and 20 hours and 11 minutes. So I've been going for quite some time, and I've been here, I've turned the aircon. This is where I came in and turned the aircon on, and I turned the aircon on again this morning. It's, you know, ramped back up. So the temperature in the lab does change by, you know, maybe up to 5 degrees C variation. Depends on whether or not I've got the aircon, when I leave the aircon on or off or not. When I've got the aircon on, I've actually measured the aircon in the temperature in the room to be stable within plus minus 0.5 degrees C. So that's what the aircon cycles through. There's about a 5-minute cycle time between when it switches on and off to maintain the temperature here in the room. Anyway, this looks like you can probably see some of the multiplexing on the display there. You can probably see a bit of flicker there. At least I can on my LCD screen. Now, if we have a look at the data here on my Advantest meter, and I'm going to assume that my Advantest meter is like spot on. You know, it is my reference standard, and I have actually confirmed that with my other reference gear. It is pretty darn good. It's way better than spec. It's, you know, way better than its calibrated spec. Even its 24-hour spec, it's actually better than that absolute. So I'm pretty damn confident in this Advantest meter. It really is kick-ass. Now, you can see that there's a lot of noise in here, and this looks like a huge variation, right? But it's not really, and I'll show you that in a second. And now, so this is the total data over that almost 2-day period there. And so because we've got it set to all. Now, if I set it to recent, you can actually see the little tiny amount of noise. You can actually see the individual bit changes almost within that, you know, within the sampling limit there. And as I've said in the review for this Advantest meter, its resolution is actually better than its nominal 6.5 digits when you're in this trend display mode. So I forget the exact figure, but it's like at least like 7.5 digits or something like that. So it's pretty darn good. That's why I love the login mode on this thing, because you can get some excellent resolution, better than what you get if you actually go into the, you know, pure number display like that. And that's how far we're off in terms of, I can actually jump between these things. Trend chart, there it is. So we'll go back to all here, but that's like I've auto-scaled that. So they're the figures up there, and that's the real-time display up the top here. So let's look at what these figures here actually represent. So what I'm going to do is actually go into the vertical range, and I'm going to change the scale here to represent the 0.05% accuracy around the nominal 1 volt that I would expect for my microcurrent. So I can go in here, so 0.05% of 1 volt is 999.50, and I'll do that for the high side as well, and you'll see how it's going to change. So what we want to do is 1 times 0.05% there, and then we want to add that on, of course, and 1.0005. So we want to get in here and change this scale to 1.0005. Oh, 0005. Bingo, 1.0005 milliamps. So that range there now from 999.5 to 1.0005, that represents the nominal 0.05% range of my microcurrent here, and you can see how it's well within that window, not in terms of not only in terms of absolute accuracy, it's only, you know, a smidgen, like, you know, half a bee's dick under the nominal 1 microamp, but it's, you know, in terms of drift as well, you can see that the drift is actually pretty insignificant. It's well within that, so I'm very happy with that. This Advantest unit on the 1 milliamp range, more than accurate enough, better than its spec. And if you remember back here at the data sheet, it's 1 day stability spec. That's just its stability, let alone its absolute overall accuracy, which is up here. If we program in the 0.01% into there, bingo, this is what we get, plus minus 0.01% around the nominal, so it's still inside the 0.01%, including the absolute value and the drift with, in this case, probably a 5 degrees C, 4 or 5 maybe degrees C overall change here in the lab. So that's brilliant. So I'm really stoked with this unit. Absolute bargain, I think, for $300, a precision voltage and current generator that's good enough to calibrate any, you know, at least any 4.5 digit meter. So, you know, it really is awesome, and its specs are better than the data sheet. You know, its performance is measuring better than the data sheet. So anyway, I've finished my data logging. I don't really need to, you know, save it. Not a huge deal. I've got a video record here. That's good enough for me. And so let's go back to the, let's go back to the number display here, and let's play around with it. So I'm going to screw up my data logging here, and let's see what happens. Like, you can switch the polarity of the output. Let's see what happens when I go to positive and negative. It's 0.9994. You know, let's say 40 there. Look at that. It's not far off. It's changed by, well, bugger all, really. You know, well within the spec. So that's pretty darn good. And let's see what happens when we go up 1 digit at a time. It's only a 5-digit display, but it's still very good. Now, when I first got this thing, I thought, oh, you type in the number, because it's got like a number keypad here, and you type in the number, but it doesn't actually work like that. These two are up-down buttons for this digit, these are up-down buttons for that digit, and so on. So it's really quite weird. So here we go, 999.4. Let's see if we go up 1 digit here, i.e. we're going up 0.1 microamp there. Let's see if that jumps to, still has exactly the same offset. Yeah, look at that. It jumped up, and it's still 4.1 there, and we can go up 1, and we're increasing that digit. Look at that. Look at that. That is fantastic. So that offset there stays the same, but the jumps are precisely to that least significant digit there. I love it. Or actually beyond that. So that is really, you know, quite impressive. I like that a lot. That is great. And of course, it goes up to 1.19, I think, is its maximum on all ranges like that. So now let's check out the other ranges. 1 milliamp, of course, is its maximum range, or minimum range there. I mean, you know, I can actually go down and generate, you know, 100 microamps, or even 1 microamp, or even 0.1 microamps, but then we're right down, you know, we're really quite right down in the noise, so I'm not going to really, you know, so it's not the best for generating low value currents like that. I mean, look, you know, we're just dicking around there, right? We're down at the least significant digit. Your accuracy is way out the window because you're not near the full scale there. So, let's go down, and let's go up a range. Let's go to 10 milliamps. Look at that, still well within spec. Calculated that, 0.002% absolute. Fantastic. I mean, that's inside the spec of this Agilent unit. And on the 100 milliamp range, well, look at, you know, it's well within spec again. In this case, because it's 100, it's going to be, this is going to be 0.005, or, you know, 0.004%, basically, off from absolute. Once again, assuming that our Agilent unit here is absolutely bang on. But hey, these two units being like, you know, almost bang on together, gives you really good confidence that, you know, both units are working, you know, and are well within specification, that's for sure. And of course, as I said, I've got other transfer standards which I can use to actually test precision voltage sources, precision resistors, and stuff that I can use to verify and sort of, you know, calibrate, in quote marks, my Agilent 34461A here, and I know it's well within specification, as I said, so very, very confident about this puppy. So I'm sure, I'd bet money that if I took this to a standards cal lab, it'd be well within spec, exactly what I'm measuring here. And we go negative on that. Look at that. Fantastic. All right, let's play around with the voltage mode, shall we? I'm still in current mode, so we're getting a maximum output voltage of 13.4 volts there, but let's switch on over to volts. So we're generating 1 volt. Oh, I've got to press the operate button. That's the, you know, and that's the output on-off button. And check that out. Ah, look at that. Bang on, of course, because we've got our 4 decimal places there. So not a problem. Let's go up 1 digit. Look at that. Once again, completely spot on with the jumps. There's only that offset at the end, the point, you know, the 0.000072 offset there. So that is incredible. So what does that work out to in percentage? Well, let's do a quick calculation. 1.000074 minus 1 is that times 100 equals, bang, look at that, 0.0074%. Awesome. And 10 volts, not a problem. And its lowest range, of course, oh no, its lowest range, there's 100, sorry, its lowest range is 10 millivolts. So that one is a little bit out. There we go. Least significant digit there. Oh no. Oh no. We were 4 least significant digits. But even right down on the 10 millivolt range, we're still under 0.05%. Beauty. And it's got a 4-wire input sense too, although I haven't actually been able to get that to work because I put it on 4-wire and I don't attach anything to here, and it's still displaying the current just fine. So, you know, I'm not sure what's actually going on there, whether or not it's got a measurement. I don't think it's got a true measurement mode to read back. It's just, you know, it's just actually a generator. But anyway, probably need to use a manual for that. It's got adjustable current limit set, so you don't damage anything. There's just a pot in there. You can just turn it so, you know, the operator can't come around and, you know, bang a few buttons and blow up your, you know, real expensive semiconductor under test or something like that. And they're very likely very high quality tellurium copper contacts. No doubt they sort of have that sort of tinge to them that you probably can't see it on camera, but it, you know, you can sort of tell those high quality tellurium copper contacts when you see them. And if we take a random microcurrent here, whack in our 1 milliamp, assuming it's spot on, we knew it was actually a bit low. Anyway, it's still 0.012% out from that nominal, well within spec. And the milliamps range there at 100 milliamps test current, we're only 0.03% out. That's better than its nominal spec of 0.1%. And there's the back of the unit. It's got GPIB interface, trigger and ready trigger input, ready output, operator hold. I guess you can turn that off so the operator can't do anything stupid. Calibration button, which I'm not going to mess with, of course. Selectable mains voltage, so you can safely buy this gear anywhere in the world, like here in Australia, and just switch it over. And some, looks like some BCD inputs as well for test systems and stuff like that. And a voltage limit pot on the back. Manufactured by Advantest in Tokyo in Japan. Brilliant. Japanese made. Unfortunately, no date code. We'll have to crack it open and have a look. And I can confirm after popping off the lid that this is about 94 vintage. So there you go, about 20 years old, but still very nice little bit of kit. And no, I'm not going to show you inside because I said this would be a quick video, and it won't be if I do a teardown. And I can't just blow my wad on one video, can I? So yes, if you want me to, if you want to see a teardown inside this thing, please let me know in the comments. Although I probably will anyway, eventually. So there you go. I hope you enjoyed that little look at this Advantest R6142 programmable DC voltage current generator. And I reckon Advantest is a nice little search term to whack into eBay to try and find some good bargains. But their stuff usually goes for a price premium, but I got this at quite a decent price, I think. So if you liked the video, please give it a big thumbs up, and if you want to discuss it, jump on over to the EEVblog forum. Catch you next time.